Operator precedence in Python. Today we'll discuss operator precedence, the precedence table, expressions, PEMDAS, short-circuiting with AND or, any or, conditional operators and ternary operators. We'll also discuss associative and non-associative operators. Let's begin with a quick challenge. Consider this expression. Which one of the following depicts its correct value? Pause the video and give it a try. Okay, save your answers. We'll come back to this later. This is the precedence table. Parenthesis has the highest precedence, which means they are the most binding. And lambda expressions have the lowest, they are the least binding. For the cells with more than one operator, they are evaluated left to right. Comparisons, membership tests, and identity tests observe the same precedence and chain left to right. Pause your screen and simply read these at your own pace, however little it makes sense to you. There's no use discussing precedence without first discussing expressions. An expression is a combination of values, variables, operators, and function calls. 4 plus 3. This is an expression with one operator and has the value 7. 3 plus 3 by 3. Division has higher precedence than addition. 3 by 3 gives us 1.0. Adding this to 3 gives us 4.0. But if we want to perform addition first, we can force it using parentheses. 3 plus 3 gives 6 and 6 by 3 gives 2.0. Is there a quicker way to determine what goes first? In school, you have learned about BODMAS. This stands for bracket of division, multiplication, addition, and subtraction. A synonym of this is PEMDAS. This stands for parentheses, exponents, multiplication, division, addition, and subtraction. You can remember it as an acronym for the phrase, "Please excuse my dear Aunt Susie." Now that you know what comes first, can you solve this challenge we saw at the beginning of this session? Let's see how this goes. Parentheses first, so it calculates the first operand to the division operator. Here it exponentiates 3 to the power 6. This gives us 729. Next it performs the multiplication. 3 multiplied by 7 gives us 21. Now it carries out floor division. 21 floor divide 4 gives us 5. 5 mod 729 gives us 5. Now 2 plus 5 gives us 7. Finally, 7 by 2 gives us 3.5. So the correct answer is 3.5. Python evaluates the first argument before the second. It does not evaluate that until necessary. This is called short-circuiting. The logic behind this is that we can stop executing a Boolean expression if we have already arrived at the truth value. X or Y. This evaluates Y only if X is false. If X is true, it returns X because even if one operand is true, the entire expression has a truth value of true. So it makes no sense to evaluate and analyze the truth value of Y. X and Y. This only evaluates Y if X is true. If X is false, there's no use evaluating and analyzing Y because the entire expression has a truth value of false. Consider 0 or hello and 1. For 0 or hello, it does evaluate hello because 0 is false. This gives us hello. Hello and 1 does evaluate 1 because even though hello is true, this is an AND. This gives us 1. You can also short-circuit with the functions any and all. Any stops evaluating at the first true value it finds and then returns true. What's the point of analyzing the rest of the values when we already know that at least one value is true? All stops at the first false it gets. It knows there is no point analyzing further to determine whether all values are true when it knows one value that is false. Let's take an example. Any of I for I in list 0, 0, 0, 1 and 3. This value is false, this is false, this is false, but this is true. It returns true and does not check whether 3 is true because it has already reached its answer. Let's try this with all. All I for I in list 0, 0, 0, 1 and 3. This value is false. This means it isn't possible that all values are true here. So without analyzing the rest of the values, it prints out false. We can also use conditional operators to perform short-circuiting. 7 greater than 8 greater than check of 4. 7 greater than 8 is false. Reaching this false, it immediately returns false and does not evaluate further. Finally, we can also short-circuit using ternary operators. Let's check the Boolean value for a print statement. The print function prints 2 and the bool function prints false because the print function does not return anything. Now check this one. Since print functions do not return something, the if statement evaluates to false. However, in evaluating the call to print, it prints out 2. This means it does not evaluate the call to print 1 and simply prints out 3. Some operators are associative, others are not. Associativity tells us which operators sharing a cell should be executed first if there are no parentheses to dissolve the ambiguity. The operations of multiplication and floor division are associative. Consider this expression. Now consider this one. Both give us 3, but in different ways. Let's see how. 3 multiplied by 5 is 15. 15 floor divide 4 is 3. Here, 5 floor divide 4 is 1 and 3 into 1 is 3. These operators associate left to right, evaluating the left operand first. Exponentiation is another associative operator. Take this expression. It gives us 64. This one gives us 512. 2 cube is 8 and 8 square is 64. Here 3 square is 9 and 2 to the power 9 is 512. So you see, the second statement evaluates as if 3 to the power 2 is in parentheses. Exponentiation is right to left associative. Other operators like assignment and comparison operators are non-associative. X less than y less than z is not the same as x less than y less than z or as x less than y less than z. It is rather equivalent to x less than y and y less than z. That's all for operator precedence. Now you know how to correctly evaluate confusing expressions.